Jai Hind everyone, I am Vaishali Rastogi, Assistant Professor at Department of Computer Science and Engineering at AKGEC Engineering College. Today we are having topic Look Ahead Carries Adder under the subject Computer Organization and Architecture. So let's start with the subject first. So here is the definition you can see over there. Definition says a carry look ahead adder CLA is a type of first parallel adder used in digital logic to calculate the carry signals in advance from the input signal. Let's see what the definition is saying. This CLA is a type of fast parallel adder. The word is first parallel adder means that whenever we need to add two numbers, we need a simple adder. Like I have to add 0 plus 1, then I need a adder to add these binary number, and addition would be 1. And we have several combinations of 0 and 1. It can be 0 plus 1 and 0 plus 0, 1 plus 0, 1 plus 1. So these all four minimum combination we can have in addition. So how we will deal when these number comes in a n number sequence? Like right now I am having only single digit, so I can simply add. Addition would be that here in this case I will have 1 in sum and 0 in sum and 1 in carry. This is our carry. So how we can deal when these number comes in a combination in digit? Like for example, I can have 1 0 1 0 or 0 1 1 0, 0 1 1 1 or 1 1 1. Like if I want to add these, so how I can add all this number and can have a good answer in sequence? So we use the CLA means carry look ahead adder for this kind of example. How we can deal? Wherever we can think that there can be carry, we have to merge with the summation, we have to use this CLA. So the CLA says that they reduce carry propagation time and implement addition of binary number. This is the most important thing we use in CLA. CLA basically do the reduction of carry propagation time. What is carry propagation time? It means that whenever we add some numbers, like for example, if I do this kind of addition, there's a higher chances of carry. So I can see that whenever I will add 1 and 1, I can have carry. Okay, again 1 and this one, I can have carry. So for this time we have some propagation time in the generation of carry. So we have to reduce this time and we want to implement, then we just implement the addition of binary number. Basically CLA also known as carry look ahead generator or fast adder or carry predictor. We can also call CLA with this name. So basically it is an improvement over ripple carry adder circuit. So okay, so it's a very improvised version of ripple carry adder circuit. Now we can see over here we are having 4-bit adder circuit. What is 4-bit adder circuit? Sorry. 4-bit adder means that here we are taking a good example of 4-bit addition. Like if I am having a digit 0 0 0 1 0 1 0 1, I want to add this number, okay, and I will have some answer here in summation box. So what I can assume at, I can assume this digit as A and this digit as B, okay, and here I will have sum. So like whatever the digit we are having, I can call it as A0, A1, A2, A3. Again for this I can write as B0, B1, B2, B3, and in last I can have here, these are the boxes actually, like you can draw like this, whatever digit will come here. I can consider it as sum S0, S1, S2 and S3. But there are higher chances that each every getting S0, S1, S2, S3 I can have, may or may not. This can be possibility that I can have a carry. So how I will implement this carry with to getting this number? This is basically using this special pin. Okay, this is basically what? C pin. C pin we can say as a C in is a basic carry, and again in each step we are having number of carries. There is a possibility, so we have to be ready for handle this carry situation. That's why we are having this pin. Okay, so for handling carry we are having this pin, and each step there is a chance that it can generate carry or propagate J carry. So we have to use this C1, C2, C3, C4 pins over there. Like for example, if I add A0 with V0, then there is a 100% value that I have to maintain one carry. So I can name as a C0 because it is generated by A0 and B0. Okay, so in this situation when I will add these two numbers, I will generate one carry which is C0. C0 would be add with A1 and B1. So can I have S1. Okay, so I am dealing with the 3 digits over here. One input I can say as A, B, and the another input which can be 0 or 1, which is C. Okay, so this in every step I can have this. Here I am taking the adder for 4-bit. So 4-bit is you have already seen that there is a A0, A1 and all the sequence. So I can use this digit here, A0, A1, A2 and A3, and another number for addition I can write over there, V0, V1, V2 and B3. Okay, so input values are clear. Now what I have to do, I have to apply some adders. Adder I can have two choices, full adder and half adder. Full adder, here we are using maximum. Why? Because in full adder we have one additional option which deal with C, means it can be A, B and this can be our carry or C in, and in output I can have sum and carry. Okay, so this is what? This is our full adder. So a full adder handles with the carry digit. That's why I have used this over here. So if I use this full adder in sequence of n number of circuit, so I can deal n number of digit in addition process. So let's start with this diagram. Here I can see that here one half adder is mentioned over there, one full adders there, and every adder is having two input pins as A0, B0, A1, B1, A2, B2, A3, B3. And again, because it also can have a carry, so we have another bit as carry, which is this. Okay, so every adder can generate a carry if the carry comes. So here we have to pass our previous carry to the another adder. Okay, so if addition of A1, B1 I can have as one sum, so there is a chance of carry. So I have to deal this carry with the C2 pin, and it will goes to another addition which is full adder, and it will, when A2 and B2 will be added, C2 will merge with that number, and full adder will generate another summation and carry if possible. So here I have elaborate all the complete diagram of 4-bit adder circuit. Now we have to deal with the truth table. What is truth table? We have the input signal as A, B and C in. If we consider the addition of these three variables in every possible case, what we will get? We will get this kind of truth table. So this truth table is saying that I have two inputs as A and B and another input as C in. What can be possible chances of this A, B and C in? This is basically A, it will be write as A0, B0 and So now I am going to tell you about the truth table. Truth table, we are having A, B and C in. So these three input, we are having some combinations of 0 and 1, and basis on these inputs I can have a output as C out. C out is nothing but the carry which is coming after addition of these three input pins. So let's start. I can have a good combination. Earlier I have told you that 0, 1, 1, 0, 0, 0 and 1, 1. These four possible cases I can have an addition, but the situation is another carry pin can come which can be 0 or 1. Okay, so first I will take carry as all 0, and again I will take carry as 1. One time carry would be 0, one time carry would be 1, and the all possible combination would be like this. Okay, so let's start. I'm just going to have this 0, 0 and 0 case. Okay, so what is this case? This is this one, 0, 0 and 0. So if I add 0 plus 0 with carry 0, so what I can have in sum is 0 and carry is also 0, means nothing. So C out is having 0. This is none, no carry. Okay, again 0, 0 plus 1. 0, 0 and 1 is carry. So add these. I will have in sum is 1 and carry is 0. Means again 0 carry. Okay, this case. And third case is saying 0, 1, 0. Means this was the case of 0, 0 and 1. Okay, so another case is 0, 1 and 0. 0, 1 and 0. This case. So add 0 plus 1 with carry 0, which is sum is 1 and carry is 0 again. So again I am having no carry. Another case 0, 1 and 1 means 0, 1 and 1. This case. So 0, 1 with carry 1. So what would the answer? Sum will have 0 and carry will have 1. Okay, so here I can see there is a carry which is 1. So I can write over there the carry is 1. But what is propagate? Okay, what is propagate? Propagate is nothing but the situation whenever the carry is in output is coming from the previous carry value. If another carry is coming from addition, like if I am adding 1 1 1, so 0 plus 1. This situation, because carry is generated from here, so here I will just write as generated carry. It is generated carry. Okay, because this is generated by A and B. In this situation always we will write as 1 as a generator. Whenever like I have situation 0 and 1, and in this case there is no carry, but if already we are having any other carry which is C in, so it is 1. Now in this case again I will have 0 as sum and 1 in a carry. In this situation the carry is propagated because this is not coming from A and B. This is coming from the previous C in value. That's why I'm saying this carry as propagate carry. Okay, I think you have understood the concept of propagate. Whenever the carry is coming from the C in bit, this time the carry is propagate carry, and whenever the carry is coming from the A and B, this time the carry will be as a generated carry. Okay, so what we have discussed? We have discussed 0, 1 and 1. Now we are having case 1, 0, 0. Means 1, 0 with 0. Okay, let's add 1, 0 with carry 0. Again, we have 1 in sum and 0 in carry. So no carry. Now we are having 1, 0 with 1 carry. Means 1, 0 with 1 carry. So what will be the output? Sum is 0 and carry is 1. So here the carry is 1 and it is also propagate carry. Again, in this situation, 1 1 0, 1 1 with 0 means 1A, 1B and 0 is carry. So here the sum is 0, carry is 1. Carry is 1. But it is coming from input A and B. Hence, it is a generate carry. Okay. And the last value is basically 1 1. Again 1 1 with 1. Means 1 in A, 1 in B and the C in is 1. So in this situation, the sum would be 1 and again the carry would be 1. So it is generate propagate carry, because in this situation we can see that carry is coming from A and B. One carry is coming from A and B, and also we are having one carry from C in. In this situation, we have both options. We can see it as a generate oblique propagate carry. Okay, you have understood the working of truth table for CLA. Okay, now next move forward. Here we are having a logic gate diagram of CLA. How it is working? It is basically nothing but the complete full adder diagram for a single part of carry adder, because earlier we have seen that there is a 4 circuit to construct a single CLA. So this is nothing, this is but the single part of for CLA. Okay, so let's start. We are going to study only this single part over here, and if we merge for the same circuit, we can have complete logic circuit for CLA. So we are going to understand what is the first single part, what this part is saying. Here we can see we have three input like C in A and B. Okay, if we are dealing only single part, we can write as A and B, but here we can see that we are having 4 circuit in the diagram, so I can write it as AI and BI. Okay, so let's start. Here I am just starting with this A and B input. What PI is saying? PI is nothing but the A XOR BI, means AI XOR BI, because this is giving as output AI XOR BI. Okay, this is the value of PI. And again GI, you can see because there is an AND gate, so the value is AI dot BI. Okay, yeah, AI and BI. So this is generating AI BI, and PI is nothing but the AI XOR BI. So next step we can see we are having again a XOR gate and AND gate. What this gate are saying? This gate is just XORing between PI and CIN, means PI XOR with CIN, which is nothing but this. Okay, so sum is equal to PI XOR CI, CIN we can say as. Okay, so now what is the value of PI? We will put PI's value. PI is nothing but AI XOR BI. This is what? This is PI, and what we are having again CIN, so I can write as a CI. So this is our final value, which is the value of final sum. Okay, so this is the final sum value. Now we have to calculate the final carry value. Final carry, you can see over there, that is the AND gate, and combination of this and this AND is the final carry. So what this AND gate is predicting? This AND gate is connected with this CIN and this PI. Okay, so you can see as the addition of, because this is a OR gate, addition, yeah, add symbol, you can use add symbol for utilizing the representation of OR gate, which is PI dot CI plus this final GI. Okay, now we are having final carry value. This is the same over here, and again we have value of Pi. So what is Pi? Pi is nothing but the Ai XOR Bi, which is AND with Ci plus Gi. What is Gi? Gi again is having some value. Let's put Ai XOR Bi and with Ci plus what is the value of Gi? This is Ai dot Bi. So this is our final value of carry. This is the same. Okay. So you can see over here we are having some value for final sum and final carry. So this is the complete representation and the final values of sum and carry. So now next we are having the carry equations, final carry equations. Now we have to calculate the final carries for every step, because we can see that either C1, C2, C3 and C4. We are having 4 carries among with some previous C in value. So this is C1, C2, C3, C4. So we can consider it as a C0 because it is previous from C1. So again here you can see C in is the previous value, but the C1, C2, C3, C4 have some calculative value. So we have to calculate the final value of C1, C2, C3, C1, C2 and C3. Okay, so let's calculate what we have equation as a final carry. Final carry what? Pi dot Ci plus Gi. Pi dot Ci plus Gi. This was the equation for carry. So I have put it the value for Ci means 0, 1, 2, 3, 4, and we have to calculate the value of these carry while utilizing this equation. So if I put the value for Ci which is 1, so what will be the equation? Equation will say as a, because we are calculating 1 is coming from previous numbers, which is digit 0. So here we are having C1 is equal to C in dot P0 plus G0. We are just putting the value from here. Okay, again we can say that C1 is equal to if I is value 1, hence I minus 1 dot Pi plus Gi. Okay, here I am putting the value of minus 1. Okay, value of I is 1. So here I can consider as C0 dot P0 plus G0. This would be the value of C1. Again I am having C2. C2 is nothing but the again value of Pi dot Ci plus Gi. I am putting or incrementing the value of I. So for C2 I can have as a C1 dot P1 plus G1. Again C3 is equal to C2 plus P2 dot P2 plus C2 dot P2 plus G2. So now we are having some summarized value for C1, C2 and C3. Here I am just elaborating all these values in a detailed form. So I am just putting the value of C2, complete value of C2 in the equation. So I can have C1 dot P1 plus G1, which is nothing but the C2. It means C2 dot P2 plus G2. Again elaborating this equation as G2 here, again multiplying P2 with all this equation. So P2 dot G1 this, and P2 plus P2 dot P1 plus dot C1. So after applying the value of P2 I can have this final equation, and again the same with the C4. So C4 is saying C3 dot P3 plus G3. Again I am putting the value of C3 here. So C3 is nothing but the G2 plus P2 dot G1 plus P2 dot P1 dot C1 and again dot P3 dot G3. So this is the complete value of C4. Again we have to elaborate and multiplying with P3 with C4's value, what we can have, P3 dot P2 dot P1 dot C1, this with this, and P3 dot P2 dot P1, this with this, again G2 dot P3, P3 and G2 and last G3. Okay, so here I am having the final value of C1, C2, C3 and C4. So this is the final carry values for CLA, and we are just going to draw the final circuit diagram with helping of these equations. Now just move forward to the diagrams. This is the circuit diagram. Circuit diagram is basically a 4-bit carry look ahead adder. This is what? This is our C2, C3, C4, and again we can calculate as a for further bits if we are using more numbers. Okay, so what C2 was saying? C2 was saying C1 dot P1 plus G1 means C1 dot P1 plus G1. Just verify what C2 is having here. You can see P1 and C1, P1 and C1 plus G1. So here I can have P1 dot C1 plus G1 and C2. Okay, so now look for the C3. What C3 was? G2 plus P2 dot G1, G2 plus P2 dot G1 and plus P2 dot P1 dot C1 plus P2 dot G1 dot C1. Let's verify this equation, it is satisfying or not. So what it was having, the G2 is coming from here, it is G2, and these both AND gates are just giving P2 dot G1 and this AND gate is giving P2 dot this P2 P1 and the last one is C1. Okay, so final sum is the same. And for last we are having C4. What we have to verify that this equation is satisfying the circuit or not, that which is P3 dot P2 dot P1, P3 dot P2 dot P1 dot C1 plus P3 dot P2 dot G1, P3 dot P2 dot G1 plus G2 dot P3 plus G3. Okay, so this would be our final C4. Let's verify. So again we can see that G3 is directly connected to C4, which is our this part, and again here you can see P3 and G2, P3 and G2. So P3 and G2 this part, and here you can see P3 dot P2 dot G1. So this part, And again in last we are having P3 dot P2 dot P1 dot this C1. Okay, so this is this part. So you can see in this diagram I have verified all this equation with mapping all the gates and with the connection. So the circuit diagram you can also draw with using these equation. I recommend that you have to draw this diagram only considering this values, and then use some and or gates and draw this final circuit diagram. So in last, I just want to give you some brief advantage of carry look ahead adders. This is basically why we are using the meaning of advantage of carry look ahead adder. Why we are using this carry look ahead adder? Because we are earlier we were having a half adder and full adder. So basically this circuit generates the carry in for each full adder simultaneously by using simplified equation involving Pi, Gi and Cin. Because in summarization we can see that Pi, Gi and Cin, we were having only 3 inputs and we can draw the full diagram for CLA while utilizing only 3 values. So we have to we have to finally calculate the value of Pi, Gi and Cin we are already having. It can be 0 or 1. While using only 3 values, we can calculate all the possible combinations of 0 and 1. So again, this system reduces the propagation delay, okay, which is very useful for our addition, and it is also faster adder when compared to other addition mechanism. Comparatively, if we are going to use half adder alone or full adder alone, we have to use more time for utilizing this summation algorithm. So here we have discussed all the advantages of carry look ahead adder. Now we are also having some disadvantages of carry look ahead adder. The carry look ahead adder circuits gets more complicated as the number of variable increases. You have seen earlier, here you can see very complex diagram we have drawn when we were only having 4 inputs pin. Okay, so what will we have if we are just increasing the number of variables? This diagram will be more complicated. Okay, so means it will get more complicated to implement all the circuit. So the circuit for a carry look ahead adder is very expensive, because if we are using larger number of this circuit for carry look ahead adder is very expensive, because it is involving more hardware, which is dealing with more hardware is very difficult nowadays, and it also involved some more expenses. So as the number of variable increases, the circuit is also implements more complexity. Here I will write as a complexity, more complexity to handle the circuit. So it is all about the half adder and full adder combination of complete diagram. So we can call it as a carry look ahead adder. Okay, so I think you have understood all the questions. If you have any query, you can contact me. Thank you for this lecture.